So this is the Algebra 2 review for Test 5. We're going to be comparing functions. On the first page, what we want to look at is to see whether a function is even, odd, or neither. So the way we make that determination is based on how the function is presented to us. If the function is given to us as a graph, as you see here on these first couple of examples that come up, then we're looking to see the type of symmetry. If we have y-axis symmetry, which is a vertical line going right through the y-axis, then the function is said to be even. If we have origin symmetry, which is basically a 45-degree angle that goes through the origin, then we can say that a function is odd. We'll talk about the other ways to determine when we get to those examples. So let's just look at the graphs first. If I look at number 1, if I were to imagine a vertical line going right through the y-axis, this left side does not look like a mirror image of the right side. So it definitely is not going to be even. And if I were to draw a 45-degree angle through the origin, which that's also known as the equation y equals x. If you were to draw the equation y equals x, let me get rid of all this extra stuff here. This part does not look like a mirror image of that either, so therefore this one's going to be neither. Okay, this first one's going to be neither. Whereas now if we look at the one number 4 here right next to it, if I were to draw a vertical line through the y-axis, this left side does look like a mirror image of the right side, therefore this is going to be even. That's an even function. Let's work our way down the page. Okay. Oh, there we go. Alright, so let's look at number 2 and number 5. Here they're giving us the function written in the form of an equation. So what you want to do on these is to change the x's to be, make sure this is still recording, it is. We want to change the x's to be negative x's. So if I change that first x to a negative x, and then plus 2 times negative x plus 1, and then I simplify, negative x squared is going to be x squared, because a negative to an even power is a positive, minus 2x, because 2 times negative x is minus 2x, and then plus 1. So what I want to do is compare signs. If my final function ends up looking the same way that my original one did, then this is going to be even. So, and I look at the first term, well, it's the same as the term I ended up with here. So, okay, so far so good. When I look at the second term, though, oh, it's not the same. So it can't be even. In order to be odd, every term has to be a different sign. But when I look at the first one, oh, it's already the same sign. Like, every term would have had to have been a different sign. So, like, in order to be odd, for instance, this would have had to have ended up being negative. These signs were already different. This would have had to also have been negative, and then it would have been odd. So since none of those qualities apply, then this is going to be neither. When you look at number 5, okay, first thing we substitute, put in a negative x instead of that x, but now it's to the third power, minus 6, not times x, but times negative x. So I end up, a negative to an odd is still negative, and then negative times negative is positive 6x. Well, we know this can't be even because this did not end up looking exactly the same as what we started. But when we look at the signs, look, positive x to the third, negative x to the third, negative x, positive. Since every single sign was different, this ends up being odd. Let's look at the last part of this page, which is the tables. Okay. For the tables, what we want to do is compare each x to the negative x. So like negative 3 to 3, compare negative 2 to 2, compare negative 1 to 1. If, for instance, when I look at negative 3 and 3, if their y's were to be the same, and that was the same for every other thing, then we'd be looking at an even function. If the y's were to just change signs, then it would be odd. But see, like here, 30 is nothing. It's not anything similar to 6. It's not negative 6. It has nothing to do with changing signs. So I don't even need to look at the rest. I know that this is going to be neither. When I do the same thing over here for number 6, and I look at, see, negative 3 gives me an output of negative 1.5. But when I switch over to 3, oh wait, look at that, positive 1.5. For negative 2, it's negative 1, 1. Negative 0.5, positive 0.5. Since the only thing that's changing are the signs, then this is odd. If the outputs would have been the same, so if I would have had like a negative 1.5 and a negative 1.5, a negative 1 and a negative 1, if they would have been the same output, whether x is positive or negative, then we would have been looking at an even function. Okay. Let's go to the next page. All right, so here we want to state the domain and range and the end behavior of each function. All right. Well, this number 1 appears to be a square root function, and even though it's not labeled all too well, we assume by looking at it that this is an endpoint, and since this goes to the end of the window, we assume that that would be an arrow. That's what would make it a square root function. So the domain, which is how far left and how far right, we're going as far left as negative 3, but we are touching it, so it would be negative 3 with a bracket, and we're going as far right as positive infinity. For the range, which is how low to how high, now see that the problem I run into with my students with range is that we're used to looking at documents, so our eyes are trained to look from top to bottom, and we want to do the same thing with range, but range is supposed to be from least to greatest, so really we need to go from the bottom up. So as far as how low, even though this might not look like it, this arrow, if I give it enough time, it would go down forever. So my range here would be from negative infinity up until I reach that endpoint. That endpoint goes as high as 4, which now leads us to end behavior. Now the trick I taught my students with end behavior is that these values are going to repeat themselves on the end behavior. As long as your function doesn't have any discontinuities, which this one does not, we're going to see those appear now on end behavior. Let's go blue. So since x deals with the domain, I know that 1x is going to approach negative 3. I know another x is going to approach positive infinity. Oops, should have had a parentheses there. Positive infinity, comma, comma, f of x, f of x. But now the trick is to know, well, does this negative 3 go with the negative infinity or does it go with the 4? Okay, now when we look at the graph, when x is going to negative 3, it's going to that endpoint. So we're going to put the negative 4 there. Oopsie daisy. We're going to put the negative 4 there. And which means then that this arrow over here, which is when x is going to positive infinity, since it's also going down, that gets the negative infinity. Okay. Let's look at this one right next to it. Okay. This is a reciprocal function, what's known as a reciprocal function. This one actually does have a discontinuity, so it gets a little tricky here. Okay, let's go with domain and range. Well, see here with the domain, we start off going to negative infinity. That's how far left it goes. But as we go to the right, we reach this. It looks like there's a vertical asymptote on top of the y-axis, which is when x is 0. So we're gonna stop at 0, but we're never gonna touch 0. Then when you go to this other branch, it's called a branch. It doesn't matter so much that we're pointing up, or it looks like it's pointing up, because we're still talking about domain. We're going to start up on the other side of 0 and then go all the way to positive infinity. No, cut me off. See if I can write this again. So my domain is from negative infinity to 0 union 0 to positive infinity. The range, okay, on this first branch, we are going all the way down to negative infinity. But then when we go up, we also have a horizontal asymptote when the y is 0. So we're stopping at 0, starting again 0 to positive infinity. The domain and the range are actually the same. Now, end behavior gets tricky because since there is a discontinuity, we have to account for each of the branches when we do end behavior. If you look, instead of there being just 2 arrows, there's 4 arrows. So let's start off with this left branch over here. Maybe we can write it. Let's write it down here. So this one, as x goes to negative infinity, the y is going up towards 0. Oops. F of x is going towards 0. And then as the x goes, it's not going to reach positive infinity. It's going to get cut off at 0. That's when f of x goes to negative infinity. This other branch, when x is going, it goes as far left, it takes off where this other x stopped. When x is going to 0, the y was going up towards positive infinity. And then when x finally did make it to positive infinity, the y was getting cut off by that asymptote. So that was going to 0. I wouldn't be too worried about being asked about end behavior when there's a discontinuity, but if it doesn't kill you, it only makes you stronger. All right, let's go now to these other functions, which at least these will be continuous. All right, well, for domain and range, the key here, and even for end behavior, the key is to understand the type of function. This function on number 3 is exponential. It looks like an exponential growth that has undergone some transformations, but it is exponential. And hopefully you were taught that any exponential function has automatically a domain that is all real numbers. Negative infinity to positive infinity. That's for any exponential function. The range, though, is going to depend on the asymptote. Now, these have a horizontal asymptote, and because the base here is 2, this originally started looking like a growth, okay? But if we look at A, which is negative, this flipped over. So now this flipped over, that asymptote looks like that. So the range is also going to go to negative infinity. But now it's only going to go up to that asymptote, and the asymptote is at k, which is negative 4. It does not touch the asymptote, so it takes also a parentheses. Because this doesn't have any discontinuities, you can look at these values and say, all right, these 4 values, negative infinity, positive infinity, negative 4, are going to show up on the end behavior. And since the domain deals with x's, I can say x is going, 1x is going to be negative infinity, 1x is going to be positive infinity, but I got to figure out which y's go with which. Well, if you, this is where it helps to have the sketch. If you know that that flipped over the asymptote, the one that's the x that's going to negative infinity, that's what's going up to the asymptote. So that's going to get the -4. And then the x that's going to positive infinity, that's what's going to get for the y to go to negative infinity. Notice how those four values that were in the domain and range also showed up in the end behavior. Number 4 is a logarithmic function. Hopefully you also learned that since logarithmic functions are the inverse of an exponential function, now the range is what is all real numbers, but the domain is going to depend on the asymptote. This has a base of 10. So since the base is greater than 1, what it would look like, it really doesn't even matter the base. When you look at the vertical asymptote, as long as there's been no flip, because the base is 10, it would look something like this. But it doesn't really matter. The whole point is that any log is going to be to the right of the asymptote unless there is a y-axis reflection, which there is not here. So because we're staying to the right and the asymptote here is at +2, we're not going to actually touch the +2. But the domain is going to be from 2 to positive infinity. When we go to write the end behavior, these are what's going to repeat. I know the x is going to go, one of them is going to go to 2, and one of them is going to go to positive infinity. But which y goes with which? Well, if we look at the sketch helps. Okay, we know over here that the leftmost arrow, the one that was going to the asymptote, that one happens to be going down. So that one's going to take the negative infinity from the range. Let me write that because that's pretty ugly. And then the other arrow that was going to the right is also going up. All right. And for the last two on this page, these are, I don't want to call them tricky, but I'm not a huge fan of these because, you know, this is just a table. It has a beginning and an end. This first table, the x starts at -2 and stops at 2. So we don't know how far to the left or how far to the right it's going to go, but we'll just suspend disbelief and assume that this is just a part. These are just some values of a function that continues towards infinity in each direction, that it's going to have two arrows. So if I look at the x's, okay, as these x's go up, the y's, let's see, this is going up 1, up 1, up 1. All of these are going up, +1, +1, +1, +1. Everything is going up. So it looks like this is going to be some type of a function like this. Whereas the x goes up, the y goes up too. So the domain would be all real numbers. The range would be all real numbers. And then the end behavior, if you look at the arrows, okay, it's going to be that as x gets smaller, y is also getting smaller. As you go left, you're going down, and as you go to the right, you're also going up. Now, if you look at this one over here, number 6, the x's are continuing to go up, but the y's go down. Like to get from here to here is down. This is down, but then it starts to go up and go up. So that makes you believe that there's not only a change of direction, but it's probably going to end up looking like a parabola. So when we go with domain is still going to be all real numbers because parabolas go forever to the left and forever to the right. The range is going to be limited, though, by that turning point. Hey, where did we turn around? We were big, and then we got small, and then we got big again. So it looks like we went down as low as 2, but we touched the 2. So it's not going to take a parentheses. It's going to take a bracket because we touched the 2 up until positive infinity. For the end behavior, the 1x went to negative infinity, 1x went to positive infinity. No, I guess this one you wouldn't be able to get the end behavior from the range because of the fact that there was a turning point. So here you just got to pay attention to the arrows. Since both arrows are going up, whether we're going left or right, you got to make sure that the y's, and oops, I wrote that wrong. Let's rewrite that better. F of x is going to go to positive infinity. F of x is going to go to positive infinity. And that's because we had a turning point. We turned around. Okay. Let's keep the party going. Oopsie daisy. Okay, average rate of change and intervals of increase or decrease. And they only want us to put the increase or decrease on the graphs. So, all right. Anytime you see average rate of change, that means slope. So, a good thing to remember would be slope formula. So let me write it down one time for you. Where can I write this? Where would it fit? Let's just do it here. Slope formula is y1 minus y2 over x1 minus x2. And I always get kids that look at that and say, Mr. Romero, you are crazy. That is not the way I learned it. That is wrong. I learned y2 minus y1 over x2 minus x1. It's the same thing. When you have 2 points on a plane, who's to say which one came first and which one didn't? So you use whatever you want. You should end up with the same thing. Now the key is to understand, and this is where the mistakes happen. You guys see 2 numbers there and you're like, whoa, okay, that's a point. No, that's not a point. That's an interval. Intervals relate to the domain. So what I want, I want the slope here, but all they're giving me are the x's, 0 comma something, 3 comma something. I need to find the y's. How I find the y's depends on how they're giving me the function. So when I go look at this graph over here, at 0, it looks like the y was 1. At 3, it looks like the y is 8. So 0 went with 1, 3 went with 8. Now let's use slope formula. 1 minus 8 over 0 minus 3. That gives me negative 7 over negative 3. And if you would have used the y2 and the minus the y1, the only difference is you would have got a positive from the beginning. But even with me, negative divided by negative is positive. So either way, we get positive 7 over 3. Now, what we're looking at here is an exponential function, and if this were a roller coaster and you were on it going from left to right, all you would do is be going up forever and ever and ever. This graph does not have a change of direction, so we're either always increasing or always decreasing. In this case, it's always increasing throughout the entire domain, and this domain is all real numbers. This graph would go forever to the left and forever to the right. So this is always increasing, and it is never decreasing. Let's go look at the next one, which is also a graph. Okay, now this is a parabola. This does have a change of direction, but we'll deal with that when we get there. Let's look at the intervals. This is negative 2 comma something and 3 comma something. When we look at the graph, at negative 2, it looks like we're at 4. At 3, it's hard to see, but it looks like a 9. So negative 2, 4, 3, 9. So the slope is 4 minus 9 over negative 2 minus 3. So we got negative 5 over negative 5, which means over this interval we have a average rate of change of 1. Since it looks like for the time being, we will be taking our assessments on Google Forms. Just make sure that if you get an answer like this and it's a short response, if you have to type it in, just type in the 1. Don't type in anything else. Now, when we talk about increasing and decreasing, excuse me, if this were a roller coaster, you'd be going down, down, down. You'd hit the vertex here at 0. We're talking about the x when we're talking about intervals, and then we go back up. But at that 0 where we turn around, we technically are neither going up or down, so that 0 cannot be included in our interval of increase or decrease. So when we're talking about first, we're decreasing. This roller coaster from left to right would be going down. So we'd be going down from negative infinity to 0. But then once we turn around, like, you can't include the 0. 0 is not part of the decrease. It's also not part of the increase, but that's where you start to increase. And you would go from there to positive infinity. Alright, for the remainder of these problems on this page, it's just going to be only average rate of change. We don't have to worry about intervals. So let's see. For this next one, my interval is 218, so that's 2 comma something, 18 comma something. In order to figure out what that something is here, though, when they give you the equation, you have to substitute. So let's substitute first the 2. When I plug in the 2, I don't want that color. Let's go blue. So square root of 2 minus 2 plus 5. 2 minus 2 is 0. Square root of 0 is 0. So that 2 goes with a 5. When I plug in the 18, square root of 18 minus 2, that gives me square root of 16. Square root of 16 is 4. And if you use your fingers, 4 plus 5 is 9. So slope is 5 minus 9 over 2 minus 18. Negative 4 over negative 16. If you do not reduce, you will get it wrong. Negative divided by negative is positive. 4 over 16 is 1 over 4. So my average rate of change here is 1 over 4, positive. For the next one, my x's are 2 comma something and 6 comma something. Let's plug in those numbers. When I plug in a 2 here, that negative is not included in a parentheses with the x. So I'd have to first square the 2, all right, to get a negative 4. And then once I add 6, that also gives me 2. When I plug in the 6, I have to first square the 6 to get negative 36. So when I add 6, I get negative 30. Now let's do slope formula like they do in the hood. Every time I go to the hood, that's what I see is people doing slope formula. Now, one of the things that's a little trick, when the second coordinate that you're going to put into slope formula is a negative, you can just change it to plus. So 2 plus 30, 2 minus 6. So we have 32 over negative 4, which gives me negative 8. My average rate of change here is negative 8. With tables make life a little bit easier because you don't have to substitute. You can just look at the table. But you have to remember, these are just your x's. So 1 comma something, 4 comma something. But now just look at the table. The 1 goes with a 1. The 4 happens to also go with a 4. So you can plug that into slope formula. Let's just do this here on the left. Let me get rid of this stuff here. So for that, for number 5, slope is 1 minus 4 over 1 minus 4. You should already know that anything divided by itself is 1, but we can confirm that by saying negative 3 over negative 3 is indeed 1. That is my average rate of change. On a Google form, just make sure you enter just the 1. And lastly, one more table. The 0 that they're giving me and the 2 that they're giving me up here with the interval, those are the x's. 0 goes with 0. 2 happens to also go with 0. Gee, that's weird. Let's see what happens there. So 0 minus 0, the y's on top. 0 minus 2 on the bottom, you get 0 over negative 2. Please don't leave it like that. 0 divided by anything is 0. A 0 on the bottom would be undefined, but the 0 on top is just 0. Now, if the 0 would have been on the bottom, you wouldn't have a function anyways. It would fail a function test, but my average rate of change here is 0, which means if I were to draw this to get from one point to the next, it would be just a horizontal line. On the fourth page, we are looking at the maximum and minimum values of each function. Now, from the first two, you can tell that it's a parabola, and I guess from the third one and the fourth one, you can tell that it's squared also. And we're just going to have to assume for 5 and 6, even though we haven't done a regression, but we'll assume that those are also quadratic, which therefore are parabolas. So since a parabola changes direction, it either goes down and then up, or it goes up and then down. That vertex is what causes you to that change of direction is what allows you to have either a maximum or a minimum value. Because if you're going to infinity, that doesn't count as a maximum or a minimum. So let's look at the first one. Let me zoom in here. It's really hard to tell. But this, now we do know that there's a minimum. It's just kind of hard to see where it is. So I'm going to just have to rely on my notes. And my notes tell me that that minimum is at -1. It's hard to read the numbers. So now when we're talking about maximum or minimum, we're more worried about the y. We want to know how high or how low. So we already knew it was going to be a minimum, but now that minimum is going to be at y equals -1. When we're talking about roots, roots are x-intercepts. Where are you touching the x-axis? Which I know is a little hard to see here in the picture, but the roots here are at -2 and at 0. That's where we touch the x-axis. On the next parabola, the only difference here is that this parabola is facing down, so that means the vertex is a maximum. That's the highest you go. And I know it's hard to read the numbers. It's hard for me to read the numbers also. Just know that we're more worried about how high, that we want to know the y. And the y there, I'm being told by my sources, is 9. That's how high we go. The roots are where we touch the x-axis. And again, I know it's hard to see. It'll be easier to see on the test. -5 and 1. If you have any complaints about these worksheets, you can forward them to dustin.klein@gcpsk12.org. He'll be happy to take care of you. Alright, now these are where it gets a little bit more fun. And this is going to be hash brown TBT. Take it back to Algebra 1. Because here we're going to have to calculate the location of the vertex, because these quadratic functions are given to us in standard form. So to calculate where the vertex is located, we learned back in Algebra 1. Okay, we defined the vertex as being h comma k. And we learned that h was at -b over 2a. And then to find wherever k was, k would just be where we evaluate the function at h. Whatever you get for h, you plug it in. So we're going to have to do that here. So the first one, let's find this h. But the thing is, remember, for maximum and minimum, we want the y. We need to find where the k is. But in order to find k, we have to first find h. So -b. My b here is -3. So -3 is +3 over 2 times a, which was 1. 3 divided by 2 is 1.5. My h is 1.5. But again, that's not my max or my min. Now look, something that you can tell, because a is positive, I know that this has to be an upward facing parabola. So I know I'm going to have a min here. I just got to figure out how low it goes. So to do that, I got to get this 1.5 and plug it back in here. How you do that is up to you, up to your teacher. I know different teachers teach this differently. A lot of them just tell you plug it in the calculator. That's completely fine with me. But I like to live dangerously, so I show my kids to use synthetic substitution, which you should have learned actually earlier this year. And that's, say, 1.5, 1, -3, -4. Drop the 1, 1.5 is -1.5. This gives you -2.25, I believe. Yep. So that is -6.25. So this function, this parabola, will go as low as y equals -6.25. That's how low it'll go. Remember that roots mean x-intercepts. If I want to know where I'm going to cross the x-axis, I have to solve for this when y is 0, which could mean using quadratic formula, your favorite. But something like this, the numbers are small enough that it would behoove you to factor, and that's what I would do. My roots here would be when 0 is equal. Two numbers that multiply to give me -4 that add up to -3 are -4 and +1. So I could just say x minus 4 equals 0 and x plus 1 equals 0. And if I solve each of those, I get that x can be 4 and that x can be -1. So those are my two roots. Roots are x-intercepts. The next one, which is also a function. Okay. Now here I see that this has a -a, so I know that this is a downward facing parabola, which means I'm going to have a max. Just got to figure out where that max is going to be. So in order to do that, I got to first solve for h. H is going to be -b over 2a. Change the sign of b. So it would be now a +2 over 2 times a, which is -1. And that's 2 divided by -2 is -1. But that's not enough. I need to find the k, so I have to get that -1 and plug it back into here. If you want to just use your calculator, you have my permission. It's fine with me. But again, just to look cool for the kids, I'm going to use synthetic substitution. -1, -2, -1. I'm just putting a, b, and c. Drop the -1 as if it was hot. -1 times -1 is 1. -1, 1, 0. Oh, that's interesting. So that tells me that this function is going as high as 0, which would also lead me, but because it's 0, it looks like that's going to be touching the x-axis, which is going to affect the roots, but we'll examine that shortly. But it looks like this function has a max at y equals 0. Now to find the roots, we wanted to make the function equal to 0 and solve. So, put a 0 where the y goes. So if 0 is equal to -x squared minus 2x minus 1, you can put those values into quadratic formula, or if you're going to factor, you got to get rid of the negative. So x squared, that changes this to 2x, that changes this to +1. And two numbers that multiply to give you 1 that add up to 2, it's repeated. It's just x plus 1 times x plus 1. Same thing as saying x plus 1 squared. If I make that x plus 1 equal to 0, that gives me -1. So you can solve it more than one way, but the roots we get are -1. And the way that all makes sense is that we knew from before, let me change the color here, that we were going to have a vertex at -1, 0. And it looked like, because of that 0, it looked like it was going to be the x-axis, and sure enough, yeah, this only touches the x-axis once, and it looks like it's only going to touch it at the vertex. So the max and the root are actually the same. It's just that for the max, we want the y. For the root, we want the x. Fax machine. Finally, for a table, okay? You can think that this is a little bit tricky, but it's probably actually a little bit even easier. When we look for a maximum or minimum value, Remember that max and min means the y. We want to see what the y's are doing. So if I look at the x's, all the x's are getting bigger. But that just means we're going from left to right. And let's see, from 0 to -3, we're getting smaller, smaller. Uh-oh. Now we go bigger, 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 bigger. So we went from smaller, smaller, smaller to bigger, bigger, bigger. This is a upward facing parabola, which means we're going to have a min. This is a minimum value. And now we just look at all the y's, and what's the lowest number you see? The lowest number I see is -4. So we'll just assume that we had a minimum value at y equals -4. For the roots, okay, roots would be where we touch the x-axis, and where we touch the x-axis, that's where y is 0. So what are the x values when y is 0? And those two values are -4 and at 0, at -4 and at 0. The next table, just like before, we look at the x's, and the x's are getting bigger, but that just means we're looking at it from left to right. But when we look at the values, see, we're getting bigger here from 0 to 1, but now from 1 to 0, we're dropping, 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 dropping as if it was hot. So this parabola looks like it went up and then came back down. So that means that the vertex is going to be a max. We're going to have a max. Where is that max going to be at? Well, what's the biggest y I see? The biggest y I see there is 1. So it's going to be at y equals 1. The roots are going to be where y is equal to 0, which gives me x is at -3 and x is at -1. And then finally, we've finally made it to the last page. Congratulations. And we read here that Harris launched a rocket whose path is modeled by the graph below. So this is Harris, and his rocket goes up and his rocket goes down. This doesn't really give me any units here. But when we're talking about these height problems, it's typically you're comparing it to time. And anytime you have time, that tends to be the x-axis. So let's say this is time and this is height. And just for the purposes of discussion, I wish this problem would say it, but let's just say time is being measured in seconds. And I don't know, for height, let's say feet, I guess. It's being measured in feet. Just so that we have something to discuss. Camden, he also launches rockets, but instead of giving you the graph, he gives you the equation for his rockets. So let's see, what is the difference in the max height of the rockets? Well, that means that even though we don't see the actual picture of Camden's rocket, it also followed a parabolic motion, and we want to compare how high it is. Well, Harris, we can see it. If we zoom in here, it looks like it took Harris 3 seconds to get there, but his rocket reached 9 feet. Difference in math means subtract. So once I find Camden's height, I'm going to subtract them. Because they're giving us the equation, we're going to have to use that thing we used on the last one, which is -b over 2a. B here is 10. So let me just, I'm running out of space. So my h is going to be -10 over 2 times -1, which means that the h is 5. Now don't get that h confused with height. Remember that h is the x-coordinate of the vertex, so that's saying that it took him 5, seconds, whatever the unit is, to get up to that height, but we still don't know how high it went. We have to plug in that 5. You can go straight into a calculator if you'd like. Since I'm cooler than most of you, I use synthetic substitution. Everybody's doing it nowadays. And that goes as high as, it looks like 26. So difference means to subtract. So 26 minus 9 is 17. On the Google form anyways, you wouldn't put feet or yards or whatever, you would just put the 17. That's the difference in the height. Camden had a height that was bigger. Let's move on. whose rocket was in the air the longest. Okay, well, now we have to understand, what does it mean to be in the air? When you are in the air, well, you're not on the ground. And we can look at the picture of Harris. Harris started at the ground at 0 seconds. It went up and it came back down. So really what we're doing here is, instead of looking at the max and min, we're looking for those roots that we looked for last page. And Harris, it looks like it came down at 6 seconds. His rocket, Harris, was in the air, and Harris spells his name a little funky. I think it was a typo. Again, Dustin.Klein at gcpsk12.org. So yeah, Harris with an extra A in there. He had it for 6 seconds. But I don't know how long Camden's was in the air. Now, normally there's a trick where you can say, well, hey, look, if I reach my highest point at 5, by the time I come down, well, it should just double. It should the same amount of time it took to get up, it should take to get down. You would say 10. But what happens here, and you're gonna see how Camden is a little naughty boy. The way that you're supposed to really confirm that is by looking for the roots, and the roots we should get by being able to set this equal to 0. So look at what happens when I make this equal to 0. You can try to factor by factoring out the negative, but you're not going to find any two numbers that multiply to give you -1 and add up to -10. So the only thing I can do here is a quadratic formula, which is the other common method for solving quadratics, right? So when I use quadratic formula, x is equal to, and I can leave, for quadratic formula, I can leave that negative. So I'd be negative b, I change this to, so -10 plus or minus the square root of 10 squared minus 4 times that -1 in the front times c, which is also 1, over 2 times -1. When I evaluate my discriminant, 10 squared is 100. There's two negatives there. So 4 times 1 times 1 is 4. So I get the square root of 104. I have a discriminant of 104 over -2. Because this is a word problem, we're trying to estimate, and I take the square root of 104. I get approximately, let me change this to approximate because now we're rounding. So I get approximately -10 plus or minus 10.2, because that's the square root of 104 over -2. If I add -10 to 10.2, I get a positive. And if I get a positive and then I divide it by a negative, that give me a negative, which makes no sense because we're looking for time. You can't have a negative time. So the only one that it would make sense to use here would be the minus, because if I do that and subtract, now I'm getting -20.2 divided by -2, which is approximately 10.1. So gee, that's weird. You know, it's still close to what I estimated. We had estimated before up here that it should take him around 10 seconds to get up, but we actually got 10.1. Now the question asks us who was in the air the longest. And that is Camden. Camden had 10.1 seconds. He wins. 10.1 is greater than 6. But then why? Like, why the difference between this 10.1 that I got here from using quadratic formula and what usually would have worked, which would have been just a double how long it took to get to the height, and that's going to be revealed in this last question, which is, was Camden's rocket launched from the ground? You know, the reason why we couldn't just, if you look at this parabola, the reason why we couldn't just cut it in half, if you look at Camden's equation over here, look at his y-intercept. His constant was at 1. I guess when Harris wasn't looking, let me just to use a graph, let me see. Harris is here in red, so let's do it in blue. Camden lifted his up. Now Camden still shot, way above what Harris. He's way up there, and he came down, way later. But that's why we were getting that negative for the root, is because if the parabola would have come all the way down, it would have been on the negative side. But yeah, Camden launched it from a higher altitude than what Harris did. So maybe Camden got disqualified for cheating. Who knows? Cheating is bad. So was it launched from the ground? No. And the reason, how do we know? Because his y-intercept was equal to 1. If you plug in a 0 for all these x's, if you need like an algebraic reason why, if you plug in a 0 for this x and a 0 for this x here, those cancel out, but that still leaves you with a 1. Camden would have shot it up from a foot up. He still would. It looks like he still would have beat Harris. I mean, if you take away 1 from the height, it would have still been 25 feet. He still would have won, but it does look like he didn't launch it from the ground. Thank you for spending this time, and good luck on the test.